Welcome to today's video on Unit 6, Part 3, the tests for parallelograms. So now we've talked about what it means to be a parallelogram. Now here's how you tell if a quadrilateral is a parallelogram, and that's by the following conditions. The first one is that if both pairs of opposite sides of the quadrilateral are congruent, then the quadrilateral is a parallelogram. That's 6.9 here. 6.10 says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So here notice the opposite angles are congruent, so that makes it a parallelogram. If the diagonals bisect each other, then the quadrilateral is a parallelogram. Notice diagonals bisecting, so you have a parallelogram. And next, if one pair of opposite sides of the quadrilateral is both parallel and congruent, see here AB is both parallel and congruent to DC, then the quadrilateral is a parallelogram. So here we'll look at the next thing here. It says determine whether the quadrilateral is a parallelogram. Justify your answer. So here we notice that the opposite sides are both congruent, both pairs. So the answer is yes, it is a parallelogram. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Which method would prove the quadrilateral is a parallelogram here? Well, here notice one pair of opposite sides are both parallel and congruent. So it is the one that says one pair of opposite sides are both parallel and congruent. All right, so next it says scissor lifts, like the platform lift shown, are commonly applied to tools and intended to lift heavy items. In the diagram, angles A is congruent to angle C and B is congruent to angle D. Explain why the consecutive angles will always be supplementary regardless of the height of the platform. Well, if you notice here, both pairs of opposite angles are congruent, meaning ABCD is a parallelogram. And since it's a parallelogram, this means that AB is parallel to CD and BC is parallel to AD, meaning, spelled that wrong, meaning that angle A and angle B are consecutive interior as well as angle C and angle D. And the same goes for angle B and C and angle A and D. And consecutive interior angles are supplementary. So since it's a parallelogram and you know the lines are parallel, that means all the consecutive angles are consecutive interior, which means they're supplementary. So next it says the diagram shows a car jack used to raise a car from the ground. In the diagram, AB is congruent to BC. So AD is congruent to BC. And AB is congruent to DC. Based on this information, which statement will be true regardless of the height of the car jack? All right, so you know it's a parallelogram. Angle A is congruent to angle B. No, they're consecutive angles, so they'd be supplementary. A is congruent to C. That is true because they're opposite angles. AB is congruent to BC. No, those are consecutive sides. And A plus C is 180. No, they're opposite, so they have to be the same. So the answer is B. So in order for this to be a parallelogram, the opposite sides have to be equal. So that means 4x minus 1 has to equal 3 times x plus 2. And also 3 times y plus 1 is equal to 4y minus 2. So you distribute here. And then you move over the 3x. And then move over the 1. So you get x equals 7, and then distribute here. Move over the 3y, and then add 2, so you get y equals 5. So x equals 7, and y equals 5 in order for that to be a parallelogram. Here, you know both sides are parallel, the opposite side is parallel, but in order for it to be a parallelogram, it also has to be congruent. So 4m plus 2 has to equal 3m plus 8. So m equals 6. So in order to prove that a quadrilateral is a parallelogram, there's 5 ways. The first way is the definition of a parallelogram, and that the opposite sides are parallel. Then you have the theorems that we talked about, where you can show both opposite pairs of opposite sides are congruent, both pairs of opposite angles are congruent, the diagonals bisect each other, and you can show that a pair of opposite sides is both parallel and congruent. Which leads us to the next set of problems. So here it gives you 4 points, and you want to prove that it is a parallelogram using slope. So basically you're going to prove that the opposite sides are parallel, meaning they have the same slope. So first it might be a good idea just to draw it out on a graph. So -1, 3 is right here. 3, 1 is right there. 2, -3 is down there, and -2, -1 is here. So there's QRST. So then you want to find the slope. So the slope of QR, remember it's y2 minus y1 over x2 minus x1. So 2 over -4, which is -1/2. Then you're going to do RS. Actually, we'll do the opposite ones together. So let's do ST. So ST, so I go -3 minus 1. Or sorry, -3 minus -1. And then 2 minus -2. So it's -3 plus 1, which is -2, and then plus 2 is 4. So -1/2 as well. So then I do the other side, so QT. QT, 3 minus -1 over 3 minus, or sorry, -1 minus -2. So it's equal to 4 over 1, which is 4. And then the same with RS. So RS is 1 minus -3 and 3 minus 2. So it's 4 over 1, which is also 4. So therefore, QRST is a parallelogram since opposite sides are parallel because they have the same slope. All right. So next, it says use lengths to determine it's a parallelogram. So same concept, except now we're going to use the distance formula. So E is -2, 2. F is 2, 0. Actually, that was 0, 2. 2, 0 is right here. G is 1, -5. And H is -3, -2. So we want to find the lengths. So to find EF, we do the distance formula. -2 minus 2 squared plus 2 minus 0 squared. It's going to be -4 squared plus 2 squared. Square root, so it's the square root of 16 plus 4, which is the square root of 20. For FG, so from F to G, actually let's do the opposite one. So let's go from G to H. We go square root of 1 minus -3 squared. And then plus -5 minus -2 squared. So it's 4 squared plus -3 squared. So it's a square root of 16. 16 plus 9. So it's the square root of 25, which is 5. So notice here, we can already tell that these two sides are not the same, but let's just go with EH as well and FG just to prove our point. EH is -2 minus -3 squared plus 2 minus -2 squared. So it's 1 squared plus 4 squared, so it's going to be the square root of 17. And then last but not least, FG. FG is going to be 2 minus 1 squared plus 0 minus a -5 squared. So it's 1 squared plus 5 squared. So it's the square root of 26. So, when answering the question, you would say, no, EFGH is not a parallelogram since opposite sides are not congruent. All right. So now it says determine whether quadrilateral is a parallelogram. Well, here this one is because opposite angles are congruent. And this one is as well because the diagonals bisect each other. All right, so I'm going to let you practice with 36 through 38, and then I'll show you the answers since they're similar to what we did above. All right, I had to make it a little smaller to fit everything in, but in 36, AB is the square root of 45, CD square root of 45, BC is the square root of 17, and then AD is the square root of 17. So yes, ABCD is a parallelogram since the opposite sides are congruent. For 37, when you draw it out and you find the opposite slopes, RS and TU, well, one's 1/3 and one's 0. So since the opposite slopes are not equal, that means the opposite sides are not parallel. Therefore, it's not a parallelogram. And then for the last one, 38, given that it's a parallelogram, what are some, write as many statements that are possible that are true? Well, you could say Q and S are equal because opposite angles of a parallelogram are congruent. That means measured angle S is 75. Opposite sides are congruent, so that's what put there. And then consecutive angles are supplementary. That means R and T are both 105. And opposite sides are parallel, so RQ is parallel to ST and RS is parallel to QT. All right, so that concludes our video on Unit 6, Part 3. Unit 6, Part 4 coming up soon.